You clicked on this video because you want to see how Lemonade, CrowdStrike, and Siemens actually build their AI agent swarms. The problem is that most tutorials stop at theory and never show you the orchestration patterns that make those systems work in production. You will learn exactly how to reverse engineer those enterprise-grade architectures using open-source frameworks so you can build your own swarms without hitting proprietary locks. The landscape of multi-agent systems has shifted dramatically. We're moving from simple chatbots to complex orchestration engines that manage state, communicate, and execute tasks autonomously. The challenge for junior engineers is not just understanding the concept of an agent, but understanding how to wire multiple agents together so they do not create chaos. When you have 5 agents working on a single problem, the coordination overhead becomes the primary bottleneck. Most developers try to hard code every interaction, which leads to brittle systems that break as soon as the logic gets slightly more complex. Let us start with the foundation. The core of these enterprise swarms is not magic. It is a structured approach to orchestration that treats agents as modular components rather than monolithic scripts. The framework known as swarms provides the backbone for this. It is an enterprise-grade production-ready multi-agent orchestration library that handles the heavy lifting of sequential, concurrent, and hierarchical flows. When you look at how CrowdStrike or Siemens approach this, they are not inventing new math. They are applying specific orchestration patterns on top of libraries like this one to manage thousands of concurrent interactions. Consider the first pattern we can extract. It is the sequential flow where one agent hands off work to the next in a strict pipeline. This is common in security analysis. CrowdStrike has demonstrated this with their Falcon MCP integration. This tool connects AI agents directly to the CrowdStrike Falcon platform for automated security analysis. It is currently in a preview stage, but it proved that agents can interact with live enterprise APIs to execute complex queries. The key insight here is that the agent does not just read data. It uses the MCP server to act as a bridge, translating natural language commands into specific API calls that the Falcon system understands. This creates a verified workflow where the agent can scan for threats, analyze logs, and generate reports without human intervention. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Now consider a different pattern. What happens when you need multiple agents to work on the same problem simultaneously? This is where the concept of a swarm becomes critical. The agency swarm framework offers a reliable multi-agent orchestration model that handles concurrent execution. In this setup, you might have a researcher agent gathering data while a writer agent drafts a report and a reviewer agent checks the facts. They all run at the same time, sharing state through a central memory bank. This is the architecture that allows Lemonade to process insurance claims rapidly. The system does not wait for one step to finish before starting the next. It orchestrates parallel threads of reasoning, which drastically reduces latency. There is a third pattern that is often overlooked but essential for browser-based interactions. Agents need to navigate the web, click buttons, and fill out forms just like a human would. This is where the BB Browser tool comes into play. It treats your browser as an API. By running a CLI and an MCP server, it allows AI agents to interact with live web interfaces programmatically. This is a game changer because it means you do not need to build custom scrapers for every website. You can instruct an agent to log in, navigate to a dashboard, and extract data using standard browser actions. This capability is what makes the concept of a runnable browser template viable for reverse engineering enterprise logic. Here is the thing that changes everything. You might be looking for a pre-built template that contains the exact proprietary code from Lemonade or Siemens. That does not exist in the public domain. The research indicates that no direct reverse-engineered browser templates containing their specific orchestration logic are available. The 5 swarms concept is currently a theoretical construct rather than a documented, reproducible reality based on public sources. However, this is not a dead end. It is an opportunity. The real value lies in understanding that you can build these systems from scratch using the open-source frameworks I mentioned. You do not need to steal their code. You need to adopt their patterns. By combining the sequential flow from Falcon MCP, the concurrent orchestration from Agency Swarm, and the browser automation from BB Browser, you can construct a swarm that mimics the behavior of these enterprise giants. You define the roles, You set the communication protocols, and you implement the state management. This gives you full control and removes the enterprise locks that prevent you from scaling your own solutions. The final piece of the puzzle is state management. In a swarm, if one agent crashes or loses context, the entire system can fail. The frameworks we discussed handle this by maintaining a shared memory state. Every agent reads from and writes to this central state. When an agent completes a task, it updates the state, and the next agent in the chain picks up where the last one left off. This is how you achieve the reliability seen in systems like Siemens, where a failure in one part of the production line does not bring down the whole operation. You build resilience into the architecture itself, not just into individual scripts. By the end of this, you should see that the barrier to entry is not access to secret enterprise blueprints. The barrier is the ability to compose these open-source tools into a cohesive system. You have the components, you have the patterns, you have the knowledge of how to wire them together. The next step is to stop waiting for a magic template and start building your own orchestration engine. The technology is mature enough that you can deploy production-grade swarms today without needing a team of senior architects to guide you. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.